All right, chapter 5, integration, antiderivatives and indefinite intervals. Bottom line, we're doing derivatives backwards. Derivatives backwards, okay? So take out a piece of paper and let's kind of get started, and I'll show you what I mean. So if we have the function 1/4 x to the 4. If we had the function 1/4 x to the 4, I would like you to take the derivative. Take the derivative of 1/4 x to the 4. Take the derivative of 1/4 x to the 4. Okay, the 1/4 stays in front. What's the derivative of x to the 4? The 4 goes in front, and then what do you do to the 4?
X cubed.
Subtract 1 and you get 3. Okay, let me stop there, a little slow motion action. What happened? I multiplied by 4, I multiplied by the number, and I subtracted 1. Multiplied, subtracted 1. Multiplied first, subtracted 1 second. Are we okay? And then, to clean it up, 1/4 times 4 is 1. You're left with x to the 3rd. Are we okay? Does everyone see that? The derivative of 1/4 x to the 4 is x to the 3rd. Everybody got that? Now, the question is, how do I get from x to the 3rd back to the original? How do I get from x to the 3rd back to the original? Okay? That's called antiderivative or integration. Okay? So if I go from integral, that means integration antiderivative of x to the 3rd. And for us, we're only going to deal with the letter x, so we're going to put dx. Okay? All those fancy symbols simply mean take the antiderivative. But if I take the antiderivative, work backwards, are we agreed that that's what I should get for my answer, 1/4 x to the 4th? Okay, so how do you take the integral? How do you take the integration? How do you take the antiderivative? It's the backwards of derivative. So we multiplied, then we subtracted 1. We multiplied, then we subtracted 1. What's the opposite of subtracting 1? Adding 1. So when you take the integral, the dx goes away. So I'm going to add 1. What's 3 plus 1? 4. So I have my number 4. Okay? So we subtracted 1 second. I'm adding 1 first. It's the opposite. And then instead of multiplying, what am I going to do to that 4? I'm going to divide by it. That is the entire lesson today. Add 1, divide by it. Add 1, divide by it. Add 1, divide by it. So you take the 3, add 1, you got 4, and then divide by the 4. Are we okay? Now, stop there for a second. How do I know if I'm right? Well, if I take the derivative is 4x to the 3rd. 4 divided by 4 is 1. I get x to the 3rd. So can I check this all day? Yeah. How do you check the antiderivative? Take the derivative. So not only did I teach you how to do it, but you can also check it. How do you do it? Add 1, divide by the number. Add 1, divide by the number. Why? It's the opposite of multiplying and subtracting 1. And when I take the derivative, you get it back. So, to be very clear, the integral of x to the 3rd dx, we're taking the integral, which means antiderivative. Dx just means what letter am I taking the integral of. What do? Add 1, divide by it. Is everyone okay with that? That's today's lesson. The only thing I need to add, not to be confusing, but the only thing I need to add is at the end, I need to put a plus c. Every time you take an integral, you have to put a plus c. Every time you take an integral, you have to put a plus c at the end. Let me tell you why. Let's say my original was 1/4 x to the 4 plus 3. Let's just say that was the number. Okay, well, if I take the derivative, 4 times 1/4 is 1, we get x to the 3rd. What's the derivative of 3? 0. What if this was a plus 4? What's the derivative of 4? What if it was minus 1? What's the derivative of minus 1? What's the derivative of any number? So if I take the derivative and I add or subtract any number, the derivative is still x to the 3rd. Are we okay? So when I work backwards, will I ever know if it was a plus 4 or a minus 1 or a plus 3? I'll never know. So for an integral, we always have to put a plus c for the number that could have been there, because the derivative of any number is 0. Are we okay? So if you're a little shaky right now, let me give you a quick example. What is the integral of x to the 5th? What is the integral, don't say it out loud yet, what is the integral of x to the 5th dx? Okay, now you can say, what's the integral going to be? X to the 6 over, and don't forget your, let's see, stop there. That's it. If you get that, you're on track. You're on track, you know what's going on. And you should know, how do you check it? How do you check if that's right? Take the derivative. So what's the derivative of x to the 6 plus c? Well, what's the derivative going to be? 6 goes in front. There's already a 6 on the bottom. Subtract 1. And what's the derivative of c? 0. So did I get my answer back? Yep. That's today's lesson. There's a couple special cases, but for the most part, add 1, divide by it. Add 1, divide by it. But the most important part is you understand why. Why are we adding 1 and dividing by it? It's the opposite of multiplying and subtracting 1. And we can check to make sure it works. Are we okay? So I'm not trying to make it over simple, but it's that. Okay? So going back to our notes, that's what this whole slide is talking about. You always have to put a plus c for the number that could have been there. You can check it with the derivative. That's what this is talking about. And this is basically just saying that you do get a range of answers, not just one answer. You get a range of answers. That picture. Okay. So let's say we had, well, I'm going to go through this one real quick. We'll go over this when we get to another example, showing there's a range of answers. I want to make sure we understand how to take an integral, then we'll do some word problems. Okay? So let me give you some examples, and we'll practice them first. Okay? So let's say we have the integral of x to the 3rd, or x squared, dx. Take the integral of x squared dx. Okay, what's the integral going to be? X to the 3rd over 3. Don't forget your plus c. And the plus c is going to represent any number that could have been there from the original. Okay? So understanding our symbols, that is the integral symbol. It's for the indefinite integral. It's used to represent the family of all the antiderivatives of f of x. And we write the integral of f of x dx. The dx represents the letter that we're taking the integral of. And when we're done, we'll have that new answer plus c. The integral sign, and that's the integrand, what we're taking the integral of, and the c is the constant of integration. That's the number that comes out of it. Now, as you notice, the pattern works if we're using x or t or u. It's all the same. Doesn't matter what letter we use. And when you take the integral of a derivative, you get the original back. Don't forget to put your plus c. Now, I'm going to show you, remember I talked about a few special cases? Here are the ones you need to note. So, number one, this is normally what will happen. You're taking the integral of x to the n. How do you take the integral? Add 1, divide by it. Don't forget your plus c. That's what we're normally going to do. But we have a couple special cases you want to note. What's the integral of e to the x? E to the x. The integral of e to the x is e to the x. Don't forget your plus c. Why is that? What's the derivative of e to the x? E to the x. So when you work backwards, you get the same thing. Okay? Now, this one is very important. Definitely know this one. What's the integral of x to the negative 1? This one, if you work it out, you'll see why it's a special case. When you take an integral, what are you supposed to do? Add 1 and divide by it. We'll go ahead and add 1. What's negative 1 plus 1? 0. And can you divide by 0? No. So that's a special case. When that happens, what's the integral of x to the negative 1 dx? The integral is ln absolute value of x. Ln absolute value of x. Anybody wondering why? Remember, when we did the derivative of ln of x, the derivative of ln of x is 1 over x. And that's what x to the negative 1 is. Okay? So these two you want to note. You want to note the integral of e to the x is e to the x. The integral of x to the negative 1, which is 1 over x, is ln absolute value of x. And don't forget to put the plus c. Don't forget to put the plus c. And then the last one, number 4, if there's a number in front, just like with derivatives, you pull that number out. And if you're taking the integral of a few different things, you take the integral of each one. Question?
Can you go back like you said?
Sure. Oh, just to see it? Gotcha. Okay. So basically, the ones you need to know right now, the integral of e to the x is e to the x. The integral of x to the negative 1 or 1 over x is ln absolute value of x. Everything else is going to follow the same rules. Add 1, divide by it. Add 1, divide by it. If there's a number in front, pull that number in front. If you have a couple things being added or subtracted, you take the integral of each one, just like you do with derivatives. Okay? So basically, we just need to practice, practice, practice. So I'm going to give you one at a time, but more importantly, I want to explain to them why the answer is the answer. Okay? So the first one's a little bit weird, but we're going to talk about it. Okay? I want you to take the integral of 7 dx. Now, I'm going to explain this two different ways, because remember, the most important is that you understand everything. What would the integral of 7 be? A regular number like 7. Any guesses? See? Yep. 7x is correct. Why? What's the derivative of 7x? 7. What's the derivative of 8x? 8. 10x? 10. So where did this come from, right? If I was working backwards, it came from 7x. And don't forget to put a plus c. Okay? If you want a better explanation, because again, one explanation is take the derivative of 7x, you get 7. That's how you check all of them. Another way to explain it is I don't have a variable here. I don't have a variable. So what if I call it x to the 0? Okay, go through your steps. The 7 stays in front. What do? Add 1, divide by it. 7x plus c. So that's another way to look at it. So what's the integral of any number? It's that number x. Don't forget the plus c. Okay? Next one. The integral of 4e to the t. Okay, I'll give you a minute, and then I'll go over it. The more I expose you to, the better you'll get. Okay? What happens to the 4 in front? Stays in front. What's the integral of e to the t? E to the t, don't forget your done. Any questions? Okay?
So plus c is always there.
1 plus c at the end.
Okay.
For the number that could have been there, because when you take the derivative, it's 0. I don't know what could have been there before. Now, could we solve for c? With more information, yes. But at this point, we just put a plus c. Okay? Next one. Integral of 3x to the 6 dx. Again, I'll give you a minute, then I'll go over it. The integral of 3x to the 6 dx. The more we do, the better you'll get. And remember, all of these you can check by taking the derivative. I'm not going to check every single one, but know that if you took the derivative of it, you would get the original back. At this point, I'm trying to give you more exposure. Okay? What happens to the 3? Stays in front. If I had x to the 6, what's the integral of x to the 6? X to the 7 over, don't forget your plus c. So my final answer would be 3 over 7, x to the 7 plus c. Again, if you want to check it, if you take the derivative of 3 over 7 x to the 7, you get 3x to the 6, and you get your original back because the derivative of c is 0. Kind of getting the hang of it? Next one. What if I have the integral of 2x to the 3rd minus 3x plus 4 dx? So if I have 3 things, what would you do? Take the integral of each one, just like with the derivatives. And you can check it by taking a derivative at the end. I'm not trying to overcomplicate it, but also not trying to simplify it. Don't want to make it complicated, don't want to make it simple, just make sure we understand. Okay, one at a time. Integral of 2x to the 3rd to 2 stays. Add 1, we get x to the 4 over 4. The minus 3 stays. Add 1, you get x2 over 2. What's the integral of 4? 4x, don't forget a plus c. Now remember, the integral 2x to the 4 over 4 minus 3x squared over 2 plus 4x plus c. But can we simplify it? Yep, so just like with derivatives, we're going to simplify at the end. We get 1/2 x to the 4 minus 3/2 x squared plus 4x plus c. Questions so far? Okay, here's another one. Be careful, there's a couple special cases in there. Integral of 3 e to the x plus 4 over x dx. The integral of 3 e to the x plus 4 over x dx. Now, again, like before, when we did derivatives, it's always nice to rewrite it first. So 3 e to the x plus 4x to the negative 1 dx. But understand, that's just a rewrite. I haven't taken the integral yet. So just like with derivatives, you may want to rewrite it first, then take the integral. So the integral of 3 e to the x. The 3 stays. What's the integral of e to the x? E to the x. Plus the 4 stays. What's the integral of x to the negative 1? ln absolute value of x. Don't forget plus c. Now remember, this is a special case. You need to know x to the negative 1. Why is it a special case? If you add 1, you get 0. Can you divide by 0? No. Red flag, That's a special case. That's a special case. Okay? Any questions so far? Okay? We're just going to keep practicing. And remember, every single one you can check by taking the derivative. So let's do the integral of 5 over x to the 4 dx. This is not a special case. This is not a special case. This is a regular one. What should you do first? Rewrite it. But there's nothing special about this. Don't make it harder than it is. Okay? So if we rewrite it, please understand, when you rewrite it, still write the integral 5x to the negative 4 dx. Don't assume when you rewrite it, you're done. That's just a rewrite. The 5 stays in front. What's the integral of x to the negative 4? X to the negative 3 over negative 3 plus c. Add 1, divide by it. Add 1, divide by it. Don't make it harder than it is. And if you need your calculator, negative 4 plus 1 is negative 3. Add 1, divide by it. Add 1, divide by it. And you know that I always like to rewrite it to make it simpler. So I would put negative 5 over 3, x to the third, positive 3 on the bottom. That, to me, is a final answer. They're both correct. But the last one's simplified. I like that one better. But they are both correct. All right? Now again, each one's going to get a little harder, but there's nothing more to teach. Rewrite it if needed. Add 1, divide by it. It's one of those 2 special cases. Then use that. Okay? Next one. Integral 4 cube root of t squared dt. And I'll give you a little hint. Should it be rewritten? Absolutely. How do you rewrite it? This is going to be the integral of 4 t to the what? 2/3. So again, if it looks a little weird, rewrite it first, then take the integral. I don't care if it's a negative, I don't care if it's a fraction, it's still add 1, divide by it. Add 1, divide by it. Use your calculator and simplify. And again, simplify it. So again, you may be able to add one, divide by it, but if you get lost in the simplifying, maybe that's where your issues are. So you may understand integration, but you may get lost in the little details. Use your calculator. Okay, so the 4 stays. What's 2/3 plus 1?
5/3.
5/3. Then I'm going to divide by 5/3. Don't forget your plus c. Now again, you can do this in your head. That's 12 over 5. Or you can take out your calculator and say 4 divided by parentheses 5/3. You can use your calculator. Call it 2.4 or math fraction. Call it 12 over 5. Okay? However you want to do it, that's totally up to you. There are a couple different ways of writing it. I would write it 12 t to the 5/3 over 5 plus c. But it's 2.4. That's fine. But don't get lost in the details. Use the calculator. Question?
Yeah, it doesn't matter if I wrote like 5/3 is 1.67.
Yeah, 1.67 is okay. The exact is 5/3, but I would mark it correct.
Okay.
But on your homework and stuff, they may be a little more picky. They may want the 5/3.
Okay.
Okay? But I understand it's all the same. But remember, separate. Are we having problems rewriting it? Are we having problems with the integral? Or are we having problems with the fractions? And if it's the fractions, that's what we got to practice. The integral is what we're working on today. Okay? Next one. What if I had the integral of x to the 4 minus 2 over x squared dx? Okay, let's talk about this one. So if you had the integral of x to the 4 minus 2 over x squared dx, okay, you'd be like, ooh, is this quotient rule? Are we going to do all that with integrals? And the answer right now is no. We're not doing product rule for integrals. We're not doing quotient rule. We don't have those for integrals. What we have is, can you rewrite it to make it simpler? So rewrite it, then take the integral. Rewrite it, then take the integral. Rewrite it, then take the integral. Don't wait for me. Try it. Rewrite it, then take the integral. Make sure you rewrote it correctly in a minute, but I want you to try it first. Okay? What's being divided by x squared? First, second, or both? What's being divided by x squared? First, second, or both? Both. So this would be x4 over x2 minus 2 over x squared dx. That could be simplified to x squared minus 2x to the negative 2 dx. So again, you may have to simplify first, then take the integral. So have I taken the integral yet? No, I just simplified. Now take the integral. So again, are there algebra issues? Are there issues with negatives? We've got to find where the little issues are. Okay, what's the integral of x squared? X to the third over 3. The minus 2 stays. What's the integral of x to the negative 2? X to the -1 over -1. Don't forget your plus c. Stop there. Any questions? And I would rewrite it as 1/3 x to the third. -2 divided by -1 is +2 over x plus c. Again, just like with derivatives, rewrite it first, then take the derivative. Just like integrals, rewrite it first, then take the integral. Question? X to the 3 over 3 is the same thing as 1/3 x to the third. There's a 1 up here, so 1/3. If you left it like that, that's fine. Okay? Next one. Again, this is a lot of rewriting, so I'm going to give you a chance. 2 over cube root of x minus 6 square root of x dx. Rewrite it first, then take the integral. So I've got to find out where our issues are. Is it the rewriting it? What is it at? Be careful. Mistake, if you understand the concept of integrals, mistake is going to come from little mistakes, algebra, same little things we've been struggling with. Let's see how we're doing. So, first of all, the rewrite. This would be 2 over cube root of x. Cube root of x is x to the 1/3. When it moves up, it'd be 2x to the -1/3 minus 6 square root of x is x to the what? 1/2 dx. Again, I have not taken the integral yet. All I've done is rewrite it. I have not taken the integral yet. All I've done is rewrite it. Questions so far? Okay. Now, to take the integral, the 2 stays. If you add -1/3 plus 1, what do you get? 2/3. Divide by 2/3. Minus 6. If you add 1/2 plus 1, what do you get? 1.5 or 3 over 2, however you want to do it. Divide by 3 over 2, or 1.5. Don't forget your plus c. Now again, you can use decimal or fraction, and you can use your calculator to help. 2 divided by 2/3 is just 3. So that would be 3x to the 2/3 minus 6 divided by 3 over 2. 4, or even 6 divided by 1.5. It's all going to give you the same answer, 4x to the 3 over 2 plus c. And again, what's nice about simplifying is some of you had decimals, some of you had fractions, but at the end, we all have a nice answer, 3x to the 2/3 minus 4x to the 3/2 plus c. Any questions? I can do 1,000 of them. It's just going to be the same thing over and over again. We need to be careful, rewrite it, needed, take the integral, add 1, divide by it. You have your 2 special cases. Don't forget your plus C and simplify. Questions? Now, every single time we had plus C, plus C, plus C, plus C, which is correct. So the question is, how do I ever find out what C is? And the answer is, we can get that if more information is given. Okay? So here's our first word problem, application 4. This one I'm not a huge fan of, but it's good to get us started. Find the equation of a curve that passes through 3, 5 if the slope of the curve is given by dy over dx, 2x at any point. So bottom line, I'm given the derivative, 2x, and I want to work backwards to find the original function. So if I have dy over dx, which is the derivative of 2x, how do I work backwards? How do I work backwards? What are we going to do? We're going to take the integral of 2x with respect to x. So again, you're given a derivative, and you're asked to work backwards to the original. So take the the integral of 2x dx. Take the integral of 2x dx. So the 2 stays, add 1, divide by it. Don't forget your plus c. When you simplify it, 2 divided by 2 is 1, so you're left with x squared plus c. Okay? So we had a derivative. I took the integral. Now we have the original. Well, what's the problem with the original? I don't know what c is. I don't know what c is. So luckily, they gave me the point 3, 5. Well, 3 is x, 5 is y. So f of x is y. So can I use that information that was given to find c? Yep. So y is 5, x is 3. Now solve for c. So every time you take an integral, you'll have a plus c. But if I give you extra information, you can solve for c. You can solve for c. So we get 5 equals 9 plus c minus 9 minus 9. C equals -4. So my final answer is x squared minus 4. So when we start doing applications, why would we need integral? Why are we learning integral? If you're given a derivative and you're asked to work backwards, how do you take a derivative and make it go backwards? It's the integral. So all of these application problems will be like, here's the derivative, work backwards. Well, when will you be given a derivative? Well, if I give you marginal revenue, what's marginal revenue? What's marginal revenue? The derivative of revenue. So if I give you marginal revenue, but I ask for revenue, what do you have to do? Take the integral. But then you'll have a plus c, so I'll have to give you information about that revenue to find c. But that's the basic idea. So here's a word problem. If the marginal cost of producing x units of a commodity is given by c prime of x equals 0.3x squared plus 2x with fixed costs of 3,000, find the cost function and the cost of producing 30 units. So nice and slowly, you are given the derivative 0.3x squared plus 2x. So you're given marginal cost. But what I want is cost. Okay? So how do I go from marginal cost back to cost? What are we going to do? Take the integral. So the integral of 0.3x squared plus 2x dx. But let's stop because I want you to do the whole thing now. So we're taking the integral. That's going to give me marginal cost or cost? Cost. But we have a problem. The problem is we're going to have a plus c. So what's given is they said when x is 0, our cost is 3,000. They said fixed cost is 3,000. Fixed cost means when you have no x's, your cost is 3,000. So you're going to use this given to find c. Then, after you find the cost function, I want to know the cost at 30 units. So once you find cost, the complete cost, then plug 30 into it and find the answer. Okay? So that would be a good word problem where you're given marginal cost, you have to work backwards to find cost, but you got to find the plus c, so you're given that, and x is 0, cost is 3,000, that's fixed cost. And then once you have the cost, you can plug into it to tell me how much 30 units will cost. Again, this is what simplifies and helps you take the integral to the far you can take it, find the original cost function. Once you find that, plug it into it. Again, it's easy when we do it together. It's easy if you do it on your own. This is cost or cost. Okay, let's just see how we're doing on the first step. Let's see if we took the integral correctly. Because if the integral's off, then everything else is off. So, the 0.3 stays in front. What's the integral of x squared? X cubed over 3. The 2 stays in front. What's the integral of x to the 1? X2 over 2. Don't forget your plus c. And if you do 0.3 divided by 3, that gives you 0.1, x to the third. 2 divided by 2 is 1, x squared plus c. This is my cost function. So I took it from marginal, I took it from marginal to cost. I took it from marginal cost to cost. So imagine telling your boss, hey boss, I figured out our cost function. You take 0.1 times how many units cubed plus our units squared plus something. What's your boss going to tell you? You're fired. Okay? You can't say plus something. That doesn't make any sense, plus something. So we need to figure out what that something is. So the clue they give us is when x is 0, the cost was 3,000. So what's x? 0. And what's the cost? 3,000. So this would be 3,000 equals 0 plus c. Therefore, 0 equals 3,000. So with that given, I can figure out what c is. So my cost function is going to be 0.1 x cubed plus x squared, not plus c, but plus what? 3,000. And now that you have your cost function, can I tell you how much 30 units are going to cost? Yep, what do? You plug the 30 in. Okay? And then we can say 30 units will cost $6,600. You okay? Take a minute, because we're about to do another one. But the other one's a little bit harder, because there's a fraction. Bum, bum, bum. Any questions on this one? All right. So here's the next one. A satellite radio station launched an aggressive advertising campaign 16 days ago in order to increase the number of daily listeners. The station currently has 27,000 daily listeners, and management expects the number of daily listeners to grow at the rate of S of T 60 T to 1/2 listeners per day. T is the number of days since the campaign began. How much longer should the campaign last if the station wants the number of listeners to grow to 41,000? Slowly. Notice what they give you. Doesn't say listeners. It says listeners per day. Per day. Is that a rate of change? That's a derivative. So how do I take a derivative backwards to give me total? Integral. And they tell me that at 16 days, that the station currently has 27,000 listeners. And then they want to know when you're done, how long will it take 41,000 days? So basically, they gave me the derivative function 16, 60, 60 t to the 1/2. Okay? That is a derivative. How do I take that backwards to find the original? Integral of 60 t to the 1/2 dt. Okay? But we already know what's going to happen. When you take an integral, what will you have at the end? Plus c. So you have to be given some other information. So they tell me that when t was 16 days, the total number of listeners was 27,000. So I'm going to use that to find what? C. Then we'll have our equation. Let's just stop there, and then we'll do the next part together. But let's stop there and see how you do. Simplifying, all that stuff's gonna help. Give about 1 minute, we'll see how we're doing. Okay, see how the integral came out? This would be 60 t to the 1.5 over 1.5, or you could have done 3 over 2, plus c. So my original function, 60 divided by 1.5, is 40 t to the 1.5 plus c. So did we get the integral correct? Questions there? Now the problem is we don't know what C is. So they told me that when the listeners was 27,000, that was on day 16. So I'll give you a minute to solve that if you didn't get that far. Okay, this will be 27,040 times 16 raised to the 1.5 gives you 25,000, 2,560. So minus 2560 minus 2560, C equals 24,440. Is that everybody's getting? So my original function is 40 t to the 1.5 plus 24,440. Now remember, this one tells me t is how many days of advertising and S of t is how many listeners. Because remember, the derivative was listeners per day. Now the last question is, I want to know how many days to get to 41,000. So I want to know how many days will it take to get 41,000 listeners. So be careful. Will the 41,000 go in for T or for S of T? S of T. So 41,000 equals 40 T to the 1.5 plus 24,440. subtract 24,400, subtract 24,440, 41,000 minus 24,440, which gives me 16,560 equals 40. I'm going to call this t to the 3 over 2. I'll show you why in a minute. Same thing as 1.5, 3 over 2. It's going to save me a little bit of work on the other end. Divide by 40, divide by 40. So I have t to the 3 over 2 equals 414. Now, I'll explain to you why I changed it to a fraction in a minute. T to the 3 halves equals 414. How do I get t by itself? You could do log and you could do natural log and move it in front. And again, that was the way to do it. I'm going to show you a quicker way to do it. Because it's a fraction, if I raise that to the 2/3, 3 halves to the 2/3, what ends up happening here? That all just becomes t to the 1. So if I raise this side to the 2/3, you get 55.55. Now, if you don't like that way, I'll give you another way. If you had t, let's even leave it as 1.5 equals 414. Remember we talked about how we can use ln? If I ln both sides, then the 1.5 can move to the front. No, that shouldn't help us. No, that may cause more problems later. We'll just keep it at that. Okay, now this is saying 55 days is how long it will take. Well, we've already done 16 days, so 55 minus 16 means you need, or actually we can round to 56. We need 40 more days.
What are we doing at 56 minus 16?
We've already had 16 days go by, so 56 is how many you need total.
Okay.
So I need 40 more days. Okay, but to end this chapter, let's look at the last 2 application problems we did. Okay, you're given marginal cost. You take the derivative, the integral of marginal, and you can get cost. But the problem with cost is, the problem with integrals, you always end up with a plus c. You have to be given something to plug in to find the c. Then you can go from marginal cost to cost by taking the integral. In this problem, we're given a rate of change, listeners per day. If I want to know just how many listeners, we take the integral. Again, we have the plus c. You have to have the given to plug in to find c. Once you have c, this one doesn't tell me listeners per day. This one will tell me total listeners. Then I can plug in and solve. Okay? All right. 4 sections in chapter